what we're going to do with them. Once you have a parent function, like a function f, you can transform it into a different function, function g, by applying various different transformations. We have reflections, dilations, which are also known as stretches, compresses, or shrinks, and we have shifting. Proper name for that is translations. So let's have a look at those in more detail. Shifting was probably the first transformation you learnt, and you probably used to say x minus h and then plus k, and your hk was your reference point. Well, we're going to get on to a whole family. When we get into trig, we're going to do lots of transformations with some quite complicated trigonometric graphs. And we prefer this setup. Forget about your h and your k. I'm going to move them out of the way. We much prefer this setup, where we use plus or minus a times whatever your function is, plus or minus b times x minus c, closing two sets of brackets. This bracket here is closing off the main parent function, plus d. So let's have a look at these. The first ones you probably learnt were translations. Which of these letters, A, B, C, or D, is going to shift your graph left or right, up or down? And it is hidden here somewhere. These two, your H and K, those shift the graph. They're your translations. Your reflections come from putting a negative. Now, there's two sorts of reflections. You've probably worked mostly with vertical reflections. These ones here calls horizontal reflections. Your pluses or minuses in front of a coefficient, either a coefficient in front of the function or a coefficient in front of the x within the function, are going to give you a reflection if they're negative. And these actual coefficients themselves are going to give you a stretch or a shrink of your function. So we need to know this, and we need to know how they work. For instance, these translations, we know they shift them, but which of these letters moves it up or down, and which one moves it left or right? There's two letters here, two different coefficients that could stretch our function. One of them is going to stretch it so it's tall and skinny, and the other one's going to stretch it so it's short and wide. How can you tell which one's which? Well, I use something called IHOD over. It's optional. I don't think that's normally taught at Tompkins, but this is how it works. If you have your function, say maybe these were parentheses enclosing the cubic function, so there'd be a cubed out here. Or maybe they were parentheses enclosing the square root function around this. Any change that's on the inside, so your letter B, your letter C, or a plus or minus here inside the function, is going to create H, IHOD. Inside is going to give you a horizontal change. And the weird thing about the horizontal changes is they often have the opposite effect of what you think. Like x minus c is going to move it to the right, like adding numbers to something, not moving it to the left. And they could change the domain of your function. Could, may not. And the letters or negatives that are outside the parentheses enclosing the parent function are going to give you a vertical change. And vertical changes are nice. They do exactly what they expect you to do. If you put plus, it moves it up. If you put negative, it moves it down. If you put a big number here, it stretches it big and tall. If you put a small number there, it shrinks it short. And these could change the range. IHOD over I find very useful, but you don't have to know this. Okay, so let's look in a bit more detail. So look at these different transformations here, and what I'd like you to do is sketch this into your notes and complete it. Let me give you one example. If you had a function and you added 2 to it outside the function, say this was x squared plus 2, and say this function was the squared function, say this was x plus 2 all squared, this one's going to move your function up to, it's going to shift it up to, this one's going to move it to horizontally, it's going to move it to the left because everything inside goes the other way. Okay, so pause your video in 5, 4, 3, 2, 1. Okay, I hope you've completed this table now. This one will shift it down to, this one will shift it right to. This 2 will stretch your function vertically by 2. This one's actually going to compress it horizontally. This 2 is inside, and so instead of stretching, it's going to do the opposite of what you think. It's going to make it narrower by a factor of 2. And this was going to stretch it by a half. So it's going to make it shorter by a half. It's going to compress it by 2. And this one, multiplying by a half on the inside, is actually going to stretch horizontally by 2. This part is probably something that was covered the least in Algebra 2, these ones. This is, when you see negatives, they're going to give you a reflection. A reflection outside the function is going to give you a vertical change. Now, let me see if I can actually draw. Oh, I can't even get at my pens here. Can I get a pen? I have no idea what I'm pointing to on the screen. It's covered up by something else. Nope. Ooh, that's a nuisance. Wait a minute. Let's see if I can hide that. No, that didn't help. My smart tools. Aha. Right. If I had a function doing something like this, if I have a negative in front of it, it's going to reflect it vertically. So the y's, you see this got a positive y value? Instead, this point here is going to have a negative y value. And when you think about it, that means your mirror line is your x-axis. That really seems to confuse a bunch of people. If it's a reflection over the x-axis, your y values change, so it goes with all this vertical stuff. So let's get this back to here. That would give you a reflection over your x-axis, which is a vertical change, changing all your y values. This negative inside the function is going to, its inside is going to give you a horizontal change. And if we sketch this again, if I had a horizontal reflection, this point here that's got a positive x value would end up reflecting onto this point over here. So it reflects your points over the y-axis. Okay. So a negative on the inside gives you a horizontal change, which is a reflection of the y-axis. Let's look at some examples here. So starting off quite simply here, just with shifting. Cubic function. First of all, you need to know what your cubic function looks like, and this is going to move it up to. So first of all, get an idea of what your cubic function looks like. And then let's look at how that would change. I need a pen again. So the first thing to do is reflections. We haven't got any. Then you stretch. You have to do reflections. The proper word for it is dilations, which are stretches, and transformations. Always do RDT in that order. So we have no reflections, we have no dilations. So then we have to translate. This plus 2, here's my cubic function. If I put parentheses to enclose everything that's being cubed, this 2 is on the outside. So that's a vertical shift. So it's going to go exactly how we expect it to go. It's going to take it up 2. So start off with your reference point, move it up 2. Then consider these points, the -1, -1, the 1, 1. First of all, it's not being reflected, it's not being stretched, so I just take it from where it is and move it up 2, and this one the same. Now just draw your graph and it would go like that. Ooh dear, I'm trying to draw with my mouse, it's horrible. Whereas let's look at the next one. This is going to move it left 2. So this point here would move left 2. There's no reflection or stretching, so I can pretend that's sort of like the origin and draw in my parent function again from that point. It would go like that. Ooh, I missed it. Go like that. It's hard drawing with a mouse. And the last one we have on this screen. This one, that transformation there is going to move it right. I'm trying to draw with my mouse. Right 1. And this one's going to take it down 2. So get your reference point, move it right 1, down 2. There's no stretching or reflection, so I can just draw in this basic shape from there. Go through there, and draw it in. That's not too bad, is it? And